Hi everyone, thank you for joining my session. From ghost assets to infrastructure drift, don't get spooked. We'll start with a short intro and continue with a reminder of the concept of infrastructure drift. We'll cover what ghost assets are and the top 5 ghost assets according to more than 100 AWS production accounts. We'll continue with what you can do about ghost assets to prevent some nasty stuff from happening to your cloud. My name is Naor. I currently work as Director of Product Management at Firefly, the cloud asset management platform for DevOps, site reliability, and cloud engineers, driven by infrastructure as code. A bit about myself. Before joining Firefly, I worked at F5 as a Senior Product Manager in Application Security, where I led the web application firewall product. Before that, I worked for the Office of the Prime Minister of Israel as a Security Research and Analytics Team Lead. And before that, I served at Unit 8200, doing mainly network security research and data analytics. So in the past decade, I've got a mixed background in DevOps, cloud, security, data, and networks. So what do you need to know to gain some valuable knowledge from this session? Well, not too much, but you need to understand the following concepts. Cloud. Throughout the session, I will mainly show examples from the most significant public cloud to date, Amazon Web Services or AWS. But any cloud background is sufficient. The session is as relevant to Azure, Google Cloud, and other cloud service providers. Infrastructure as Code, or IAC. This session focuses on examples from HashiCorp Terraform, although relevant to Pulumi, CloudFormation, and other IAC technologies. I recommend understanding state files, HCL, which is HashiCorp configuration language, and some terminology such as providers. When I say cloud asset, I usually mean a Terraform resource when it is a managed one. Infrastructure drift, a short reminder. When we manage cloud assets with Terraform or any other infrastructure as code, we do that for multiple reasons: speed, consistency, versioning, documentation, and decreased risk. The opposite of managing cloud asset with code is doing it manually through the cloud console or user interface, what we like to call ClickOps, which stands for click operations. Infrastructure drift starts when the infrastructure drifts away from the code. When we want to make just a small patch here and there, we tell ourselves that we'll add it to the code later, but we usually never do. So we started with a fully managed, codified infrastructure. We used ClickOps to make just a small patch here and there, and now our code no longer describes the actual state of our cloud. When we run Terraform plan, for example, we get a list of all the changes we've made manually, and we're stuck. We have to decide whether we want to revert everything to the older codified state or adapt it somehow, meaning changing the code to match our manual changes. These drifts are all about changing existing assets, which we created from code. This session focuses on the very existence of those assets, as you'll see right away. So what are ghost assets? We have our codified managed assets created with code using the Terraform apply command. Someone or something completely removed one or more of those assets with API or ClickOps, meaning manually. They now cease to exist in the cloud. But because of the fact that they were initially created with code, they are still in the code itself and in the state file, which refreshes once you apply your code again. These assets are what we call ghost assets. They can hurt cloud reliability by causing downtime or production issues, creating redundant costs, and generating security issues. Anyway, there are two options. You either wanted to delete that asset, which you no longer need, and what can happen is that it can be accidentally revived. It is still in the code, so applying your code will just recreate that asset again. The other option is that you did not want to delete it. You still need it in your cloud deployment, but it was deleted by mistake, and now it is not available when you need it. It can be a storage backup, a compute asset such as Lambda that can cause downtime, or a database replica, you name it. What is most certainly true here is that you have a problem. As a cloud asset management platform, Firefly's customers integrate their AWS accounts, so we have plenty of data to look at. By looking at only part of them, more than 100, we get a fascinating sorted list of the top 5 ghost asset types. EC2 instance, a compute asset, essentially a virtual machine. IAM policy, which is all about identity and access permissions. SQSQ, which is a managed messaging queuing service. CloudWatch metrics alarm, an alert configuration on a cloud metric such as CPU utilization for an EC2 instance, or volume write bytes for an EBS volume. And security group, which is basically a virtual firewall. So, EC2 instance is one of the most critical assets. It is used by almost any AWS customer for compute. Again, essentially a virtual server you can do anything with. It was also the second service AWS introduced back in August 2006, second only to the S3 storage service. So what can happen if an instance is accidentally deleted? Well, in that situation, we mainly have reliability problems. Imagine we have a multi-service application deployment. An EC2 instance can run its web server, a backend service, a web data scraper, and even a database. If this production instance is suddenly gone, you will definitely suffer from downtime. Services will not be accessible to customers or any other type of consumer. It can also remain undiscovered for days or weeks if it's not a core service used for any operation. What can happen if a deleted EC2 instance is accidentally revived? When was the last time you spun up a temporary instance just to try a new tool, open source, or any other experiment? If you deleted that managed codified instance manually and another engineer or team hit the Terraform apply, it will be revived and you will pay for it. It can be anywhere from 3 to 4 digits dollars a month. What about security? In that case, you have an instance that might be publicly available to the internet, running old, unmaintained, unneeded code. You know where this goes. A breach. IAM policy is at the core of identity and permissions. Any user or role can be attached to it and get its needed permissions, such as writing or reading from specific services. It is used for manual and programmatic access. Managing policies as code have tremendous advantages, especially when implementing least privilege permissions. Upon deletion, the role is detached from any entity attached to it. This means that any permission granted by the deleted policy is now revoked. Production processes can lose their ability to write and read data, and customers can lose access to services. But what about security? Policies can include explicit deny statements that are always stronger than allow statements. They can protect against unauthorized actions and act as a guardrail that, once removed, can pose a real threat of excessive permissions. SQS is Amazon's queuing service, a central pipe in any meaningful project, usually connecting between producers who send messages to it and consumers who read from it and do something with the data. When accidentally deleted, it is no longer available for the producers to send messages and for the consumers to read from, therefore causing operational damage to any dependent service, hurting the reliability of data and halting jobs already in the queue. The CloudWatch metric alarm is an elementary configuration for monitoring cloud assets. Whether it's the CPU or memory utilization of an EC2 instance that can lead to changing its type or space in your EBS volume, the notifications it generates are actionable and essential for production environments. It's pretty evident that when such an alarm is deleted, it can cause SLA, service slowdown, SLA problems of course, service slowdown, and even downtime. Security groups are virtual firewalls that control the traffic that is allowed to reach and leave assets that they are associated with. When accidentally deleted, it can remove needed access to a specific asset when deleted because multiple security groups can be assigned to one asset. It can be detected late in the game, causing downtime. Although for this type, it is a bit harder to accidentally delete, as it is not allowed to delete an attached security group, whether to a network interface or an instance. This table summarizes the asset types we discussed. Those are just the top 5, and any other deleted type can cause cost, security, and reliability issues. So, what can we do about this? Well, you should all become your own cloud Ghostbusters. There are several ways to tackle ghost assets, and we will cover just some of them. There are 4 categories that we look at when we talk about taking care of ghost assets. 1 is detecting a ghost asset. It means catching when an asset is deleted somehow, but is still in the state file. 2, alert is the ability to send a notification to your favorite chat-up solutions such as Slack. 3, fix means the ability to make a change to your actual code or run a CLI command. And 4, prevention. Prevent means making sure that this never happens in the first place. We'll start with our SaaS solution, Firefly, for which we have a completely free tier. No credit card needed. You can start using it today, and it supports the detection, alerting, and fixing of ghost assets. We'll talk about prevention that can be achieved by locking your cloud for any ClickOps activity. Although largely theoretical, some teams might be able to get it done. We'll talk about ClickOps, an open source that lets you detect and alert on ghosts. Finally, we'll mention driftctl, which helps you detect ghosts as well. So, this is what the Firefly inventory looks like. As you can see, we have a table with all of our cloud assets. Up there, we filtered to show only ghost assets. We have quite a few of those. Let's focus on one of them, an EC2 instance. So this instance was created with Terraform code. It is no longer in the cloud, meaning it was somehow removed. It is still in the code and in the state file. As you can see here, we have an alerts channel on Slack, and we send alerts on ghost assets, so we can immediately know when a codified managed asset is removed from the cloud. We can also look at the asset data, and in the IAC tab, see exactly which stack or state file manages it and which Terraform code created it. When we click on the code link, we will get right to the code in Git. On the left, you can see the resource code in Terraform that created this asset. And if it was accidentally deleted and we want to revive it, we can just run the following command: terraform apply -target AWS instance, which is the type, .bar3, which is the resource name from the code. If we want this asset removed from the code, we click on remove asset code, and we instantly create a pull request to remove the relevant resource block from our code. Once approved, this asset will never come back unexpectedly. Here you can see the pull request on GitHub, and that concludes the first solution. Well, the ultimate prevention option is to lock your cloud, meaning disallowing any non-read ClickOps through the AWS console, and allowing only your infrastructure as code solution to make changes. This way, you make sure you never have any ghosts or drifted assets as well. Still, the cost is relatively high, especially when we want to make a quick fix manually after a PagerDuty alert woke us up, instead of writing Terraform code at 2 a.m. But it is still possible, and it's definitely worth a try. ClickOps is an open source solution that helps you detect and alert any ClickOps actions someone made in your cloud accounts. It can be provisioned using AWS Control Tower for multi-account support, and it is basically using CloudTrail logs to detect those actions. You can also alert Slack using a webhook configuration. ClickOps also provide a Terraform module that is used to provide all the needed resources, including a dedicated Lambda. It seems like a great solution if you are willing to invest time configuring, monitoring, and troubleshooting it. driftctl is another open source tool that works with state files. So you don't need any unique cloud deployment, but you still need to invest the time and automate using cron jobs or any other automation to catch ghosts as they happen. If you want any alerts, you will have to build them yourself. In addition, I recommend being careful when handling state files, as they might contain sensitive information when not cleaned, and can cause damage if accidentally changed. Let's wrap up. Ghost assets are dangerous. They have to be detected and fixed this way or another. We can prevent redundant costs, reliability issues, and security exposure. I will end with our favorite blessing at Firefly. May your infrastructure never drift. Thank you.